So we're going to be talking about logarithmic functions today. This is the logarithmic function where b is your base. And we're going to be graphing these. So before we graph a log, let's talk about its inverse. Do you guys know what this logarithm is called? Yes, it's the common logarithm. The common logarithm has a base of 10. That's why the inverse is 10 to the power of x. And we know how to graph its inverse. So let's go ahead and graph the inverse before we graph the log. So I'm going to make a table. I'm going to plug in these numbers for x and figure out the y value. 10 to the power of 0 is just 1. 10 to the power of 1 is just itself. And 10 to the power of 2 is 100. Now, if we go to the negative side, 10 to the negative 1, you just flip it. It'll be 1 over 10. 10 to the power of negative 2 would be 1 over 100. Okay, so let's go ahead and graph this. When the x value is negative 2, the y value is very small. This as a decimal is 0.01, so that's very small. It's down here. Okay, this as a decimal is 0.1, so at negative 1, it's going to be at 0.1, also very small. Then the next one is 0, 1, right here. Next one is at 110. I'm just going to estimate it and say 10 is up here. And then 2 to 100. It's way off the graph, off the page. So it goes like that. So guys, that is the exponential function, 10 to the power of x. Now, if I know that they're inverses, what can I do to this table so that I can graph the log? Do you guys know what we do with inverses? Exactly. We switch or flip the x and y value. So now this is my new y values. These are my new y values. And these are my x values. 0.01, 0.1, 1, 10, and 100. So let's go ahead and graph the log parent function. So this is x at 0.01. Well, if this is 1, 1, 0 is here. 0.1, negative 1 is like right here, very close to 0. And negative 2, 0.01 at negative 2 is also very close to the y-axis. And then 10, 1 is up here. So it goes like this. That is what your log looks like. So if you want to graph a log, all you need to do is graph its inverse and swap the points. Switch x's and y's to graph a log, okay? So we're going to take this same idea and do different types of logarithms. So let's go ahead and go to the next example. Here, I have log base 2. Since my base is 2, what is the inverse?
2.
Yes, 2 to the power of x would be the inverse. So I'm going to go ahead and create this table. And let's go ahead and figure this out. So if I plug in a negative 2, this will be 1 over 4, 1/2, 1, 2, and 4. Okay, so this is the inverse table. Now, that means log of base 2, we would swap x and y. So this would be negative 2, negative 1, 0, 1, and 2. This would be 0.25, 0.50, 1, 2. I'm sorry. I didn't write that right. I'm putting these values right here. So this would be 1, 2, 4. I switched the x's and y's, that's all. Okay, and I just made these decimals. 1/4 as a decimal is 0.25. 1/2 as a decimal is 0.5. I just changed them to decimals. Okay, so now you can graph this. So 0.25 is going to be at -2. I'm going to make my, I'm going to go by, I'm going to make this 0.25, 0.5, 0.75, 1.25, 1.5. Y'all see what I'm going by on the x-axis? Okay. So I'm going to go ahead and graph this. You can go by whichever scale you want. You don't have to copy me. Just graph it. So at 0.25, I'm at -2. At 0.5, I'm at -1. At 1, 0, I'm there. 2, 1, I'm there. Oh, 4 and 2 is way over here. Okay, it'll look like this. Maybe go by 0.5s. That would be better to fit. But is that okay, guys? Where is my asymptote? Yep, this will continue to get closer and closer. So your asymptote, it crosses the x-axis at 0. Okay, it did not move left or right, so this is still your parent function. Okay, your x-intercept, we said, is 1, 0. Your domain goes to 0 to infinity. Your range is always going to be all real numbers for a log. It will go forever up, forever down. Now, let's talk about the end behavior. Guys, follow my highlighter here. I'm going to highlight. As my, first, let's draw the asymptote. Everyone draw the asymptote, please. This is the asymptote right here. This is the line that'll get very close to but not touch. So guys, as my x values approach my asymptote, what's happening to the y's? Yes. So as x approaches the asymptote, it approaches -infinity. Okay, now let's move to the right. As x goes to the right towards infinity, what's happening to the y values? It's going to infinity. Okay, so that's how you do the end behavior. Yes. So for asymptote, whenever we're talking about logs, your asymptote will always be vertical. Okay, you can think of it like this. L, it's going to be vertical. I like to remember it like that. Draw vertical arrows. For log, your asymptote is always vertical. So your equation will always be x equals some number for asymptotes when we're dealing with logs. Okay? Last unit, we were dealing with exponentials. With exponential equations, your asymptote was horizontal. So it was y equals. Okay? All right. Let's do a harder one. Let's go on. Well, let's just talk about this one real quick. Guys, what would be the inverse for an ln for natural log? Yes, e to the x. So you would have to make a table like this and then swap it to graph that. Okay, that's the inverse. Let's talk about some transformations though. Let's look at number 5. Okay, so real quick. Do you guys remember what would be the inverse of the common log? What's the inverse of this? Yes, 10 to the power of x is the inverse of this. Whenever your base is blank, that means your base is 10. Okay, do you guys remember what the log of x graph was, the table? Go ahead and copy it. I think it was -2, -1, 0, 1, 2. And this was 1 over 100, 1 over 10, 1, 10, and 100. We already did this in the previous problem. Okay. Does everyone understand how I got this log? Okay, this is the log table. If you need to do the previous step of getting the table for 10 to the power of x, you can do that too. It's just flipped. Okay. All right, so this is the table for a log. Now, I'm going to highlight the transformations that happen. First, all the y values are being multiplied by -2 because this is called a vertical stretch, and it also flips across the x-axis. This is a vertical stretch by 2, and it's also a reflection across the x-axis, reflects over the x-axis. These affect the y values. Also, this -1, down 1, that also affects the y values, okay? The only thing that will affect the x values, let me highlight the x values. This side is your x values. And the only thing that affects your x values is what's inside of the parentheses. That's the only thing that will affect your x values. Everything else affects the y value, okay? So let me highlight that for you. Here are the y values, -2 and -1. That affects this side of your table, the y values, okay? So let's look at the x part. I know that this +3 on the inside, it means it went to what? What direction did it go? Yes, it went to the left 3. Okay, remember it's opposite. So my graph shifts to the left 3 spaces. So for these x values, we're going to subtract 3 from all of those x values. So guys, go ahead and grab your calculators. 1/100, that's just 0.01. So you're going to do 0.01 minus 3. And tell me what you get. Negative? Okay, 2.99. Now the next number is 0.1. Subtract 3 from that. So 0.1 minus 3. Negative 2.9. Perfect. Now the next value is 1. You're going to subtract 3. Next value is 10. Subtract 3. Next value is 100. 97. Okay, so that is how your x values were transformed because our graph went to the left 3 spaces. Okay, now we're going to transform the y values. Let's transform the y values. We did the x's already. Okay, so now we're going to look at what's highlighted in yellow. Okay, so first we're going to move left to right. First, your y values were multiplied by a -2. So guys, what's -2 times -2? 4, and then subtract 1. Next, -1 times -2 is subtract 1. 0 times -2 is subtract 1. 1 times -2 is -2. Subtract 1, it's -3. Last number, 2 times -2 is -4. Subtract 1 is -5. So this is your transformed graph. This is the graph that they gave us. I'm sorry, I keep saying graph, table. Okay, this is our transformed table. Okay, now let's go ahead and graph this. So the x value is -2.99. So if this is 1, this is 2, this is -3. I'm about right there. -2.91. Is about right there. My points keep disappearing. There we go. Okay, next point. -2, -1, right there. 7, -3. 1, 2, 3, 4, 5, 6, 7, -3. And then 97, -5, that's way over there. So this is what your graph looks like. Okay, now let's answer the questions. Your domain, where's the left side at? Yep, -3, and it goes off to the right, so that's infinity. Your range is always the same, all real numbers, or you can write -infinity to infinity. it goes forever up, forever down. Let's talk about the end behavior. The end behavior. The end behavior, as x goes to infinity, as we move to the right here, your graph also goes to infinity. I'm sorry. As the x value goes to infinity, the y values goes to negative infinity. Let me explain that one more time. They have it pre-written for us. Okay, so guys, as we move to the right, as x goes to infinity, you guys see what's happening to our y values? It's going down, so that's why it's negative infinity. Okay, now, as my x value goes towards my asymptote, as it goes to 3, what happens to the y? It goes up. So that should be a 3 in there. Okay, let's estimate the x-intercept. I'll take an estimate for the x-intercept. Your x-intercept is somewhere between, it's about right here. So I'll just put negative 2.5. How's that? Okay, and oops, we left this out. So guys, make sure you have a negative right here. This is negative 3. Right here is your asymptote. Okay, and then finally your asymptote, which I just drew in red, is x equals negative 3. So guys, these numbers should match. Your domain, your end behavior, and your asymptote should all match. Okay, they should all match. And it is always opposite of what is inside of these parentheses. Logs are affected by horizontal movement. Okay, so you're going to determine the asymptote by if it moved left or right, are affected by horizontal movement. And I'll add the asymptote of logs. The asymptote of logs are affected by horizontal movement. Anything horizontal, left, right, reflections across the y-axis, those would affect it. Okay, I'm going to stop here.